Hello. In this seminar, I want you to graph linear inequalities on the coordinate plane, and I want you to solve inequalities by graphing. When we solve or when we graph an inequality, it's just like graphing a line. In fact, that's the first thing you're going to do is you're going to graph the line. The difference is, just like when we solved inequalities earlier, you're going to have infinite solutions. So we're going to graph what's called the half plane. So step by step, step one, graph your boundary line. If there's a line underneath your inequality, you're going to graph it with a solid line. If it's not no line, you're going to put a dashed line. That's called an open inequality. We're going to use a test point to determine which half plane we're going to be shaded. And finally, you're going to shade that half plane. And like I said, it'll be a closed half plane if it's a solid line. It'll be an open half plane if it's a dashed line. So start with example 1 here. 2y minus 4x is greater than 6. I look at this one, and if I look ahead, if I use intercepts, I'll get a decimal. So I think I'm going to solve for y. And you're going to like solving for y when you do this because it makes shading a lot easier. So first thing we're going to do, we're going to add 4x to both sides. And notice there's no x on the 6, so I can't combine them. So I get 2y is greater than 4x plus 6. Now I'll divide every single term by 2. Y is greater than 2x plus 3. No line underneath my inequality means I'm going to put a dashed line on my graph. So as a review here, we are going to do the y-intercept as 3. So I go up 3. My slope is 2, so I'm going to go up 1, 2, and over 1. And I'm going to draw a dashed line going through those points. Now, which side do I shade? Well, since it's greater than, I'm going to shade above my line here. So I'm going to shade above if it's greater than. Now, you can only skip this step if y is by itself. If y isn't by itself, then you have to use a test point and see which side of the inequality is true. And what I mean by a test point, let's do that. Let's say I picked a test point, and I can pick any number, any coordinate, as long as it's not on the line. I like 0, 0. The only time I can't use 0, 0 is if the line goes through 0, 0. So my test point is 0, 0. So I replace x with 0 and y with 0. So I get 2 times 0 minus 4 times 0 is greater than 6. Well, the left side is 0. Is 0 greater than 6? No, it's false. So I don't shade the side with 0, 0. I shade the opposite side. And like I said, if you get y by itself, it works out pretty nifty. Now let's do the same thing for example 2. Maybe you want to pause the video and see if you can do this yourself. I'm going to get y by itself again. So if I look at this problem, the first thing I'm going to do, I'm going to subtract x from both sides. I like to write the x first so it's in slope-intercept form. So when you draw your line, I'm going to say, notice x minus x is 0. So you get 4y is greater than or equal to negative x plus 2. We divide every single term by 4. So it doesn't work out really nice here, does it? So we get y is greater than or equal to negative 1/4 x plus 1/2. So my y-intercept is 1/2. So when we go to graph this, I'm going to go up a half, put my point. My slope is negative 1/4, so I'm going to go down 1 and over 4. Since your inequality has a line under it, we're going to put a solid line going through those points. We're going to have a closed half plane, in other words. We're going to shade above the line because it's greater than, so I'm going to go above the line. And you get some Zen quality here by just coloring in your graph. There we go. That's graphing an inequality. Two examples of that.